Hiya folks! So in this video I'm going to continue working on Breakout in Pygame. I'm going to run the code to show how far I'd gotten last time. So you can see the wall, the paddle and the ball was all generated, and there is some initial collision for the ball as it bounces off the walls. So the next thing I want to do in this video is add in two more stages of collision. So one is going to be collision with the paddle and two is going to be collision with the blocks. So I'll just get right into it. I'll come down into my ball class, and this is where I'm going to be handling this collision. So I already do have some initial checks. So I've got collision checks with the walls and the top and the bottom of the screen. So now I'd like to add in collision with the paddle. So to do this, I'm going to use Pygame's built-in collide rect function. Because the game ball and the paddle are both rectangles, it makes it much easier for me to check for collision. So I'll add a comment here to say look for collision with paddle, and I will use an if statement if self.rect, so if the ball rectangle collide rect, and this is where I put in the target rectangle. So this is going to be the player paddle. So if it detects a collision between the two rectangles, then I want it to change direction. I want the ball to bounce off the paddle. However, I need to determine or differentiate between collision from the top of the paddle and from the right-hand side or left-hand side of the paddle. So first I'm going to look for a collision from the top. Check if colliding from the top. So all I'm going to look for is whether the bottom of the ball rectangle has crossed over the top of the paddle rectangle. So I will use an absolute value for this, and I will just subtract the two from each other. Self.rect.bottom, so this is going to be the bottom of the ball, minus player underscore paddle dot rect dot top. And I want to add some kind of threshold for this because it's not going to be pixel perfect. So my threshold I'm going to add further up in the function. I'll call this a new variable here, and I'll call this collision thresh. And I'm going to make this 5 pixels. So as long as the overlap is within 5 pixels, then I'm going to say that I've collided from the top of the paddle. So collision threshold. And I can add this check to here. So if that's less than the collision thresh, then that means that I've collided from the top of the paddle, so I just want to flip the y speed of the ball. Self speed y multiplied by -1. However, this could give me a bit of an error in the code. So because of the speed at which the ball is moving, it's possible that it will pass through the paddle rectangle, i.e. it will collide, and then I will flip the speed. But if the ball hasn't had a chance to leave the paddle by the next iteration, then it's going to record another collision and it's going to flip the speed again. So the ball could potentially end up stuck in a situation where it's almost like it's stuck itself inside the paddle and it will just bounce up and down within it. So to add to this, I will say and self speed y is greater than 0. So that means that I'm only looking for this collision as long as the ball is moving down the way. So the speed y is a positive 1. So then I flip it and I move up the way instead. What I'd like to do to the x direction, or rather the x speed, is adjusted based on the direction in which the paddle is moving. So this makes it a little bit more realistic in that if you move the paddle against the ball, it's going to slow it down a little bit. And if you move it with the ball, it's going to speed it up a little bit. And that's why my player paddle class had this direction variable in it. So I'm now going to be able to use that. So my speed x of the ball is going to be increased by the player paddle direction. However, I want to limit this because the result could be that you could end up completely slowing the ball down or making it ridiculously fast. So I don't really want it to deviate too much from the actual original speed of the ball. So I'll define an additional variable up here where I've got speed at the moment. I will now add speed max. and I'm only going to increase it by 1, so I don't want it to deviate from the original speed by more than 1 point. So the maximum it can move at is a speed of 5. So if in these checks my speed x has exceeded this max speed, then I just want to set it back to the maximum speed. X equals speed max. So that means that if I iterate through this and I end up getting so if my speed x was already 5, then this function could potentially tell me to increase it by 1, so it would go up to 6, but I don't want it to exceed my maximum speed. So this check would say, is speed x greater than the maximum speed? If it is, then just set it to the maximum speed, so it can never exceed it. And now I need to do the same for the negative speed. So if it's moving to the left-hand side of the screen, therefore if speed underscore x is less than 0, so it's negative, and it's also less than the negative value of speed max, then I set that speed to negative speed max. Alright, so all this is doing is just limiting the speed that the ball can go up to. And lastly, I need to come back into here and add an else loop, an else statement. Actually, this one should be an elif. So this first check here was looking to see whether the collision is from the top of the paddle. And in that case, the ball bounces up the way. So the y direction or the y speed changes. However, if that's not the case, then that would suggest the collision has come from either the left or the right hand side of the paddle, in which case it's the x speed that I need to change. So this statement is just going to say self speed x multiplied by -1. So just flip the direction in which it's going in the x direction. So I'm just going to run this to check if it's all working okay. And there we go. So it's bouncing off the paddle just as intended. That's fine. So that's working well. Alright, so the other thing left to add now is to check for collision with the blocks themselves. Now this is going to be a little bit more difficult simply because I've got so many different blocks. I need to iterate through each of them, and then I need to look for what strength they have. I need to reduce that strength by 1, and then if the strength has come to 0, that means that the block is completely broken, so I need to remove it. So there's going to be a little bit of code here, and I'll explain it as I go. The important bit here I need to add is I start off with the assumption that the wall has been destroyed completely. And I'll explain why I've done this. So wall destroyed equals 1. Alright, so with that assumption made, I can now do all my checks through the collision, and if I find that there are still blocks left over, then I will just change this back to 0. So first I need to iterate through my blocks list. So the wall, if I come back up here, my wall class contained this blocks list. So when I created an instance of wall, I created this blocks list, and that contains all of my blocks inside it. So I'm going to iterate through it now within this collision check. So for row in wall.blocks, which is that list, I'm now going to be getting each of the rows within the list. So from those rows, I want to iterate through them now and look for each individual block item. For item in row, I'm going to be iterating through this now, and I check collision with each one. So again, I use the same function, if self rect collide rect, and this time my target is going to be the rectangle in the block. So item is going to be giving me the list that's within that row. So if you remember from before, when I created this class, each of the items contained, so this is the item that I'm going to be pulling, and it contains two values within the list. The first one is the rectangle, and the second one is its strength value. So I can pull each one of these with their index. This is index 0, and this is index 1. So if I come back down to where I'm doing my collision, I'm looking for index 0, because that's that rectangle. So if I have got collision, well, now I need to determine whether it's come from above, below, left, or right of the block. So first of all, check if collision was from above. So I'm going to be doing the same thing here. I'm going to be looking for that crossover between the top and the bottom. So if it's from above, then it means that the bottom of the rectangle has crossed over the top of the block. So self rect bottom minus item 0, which is my rectangle of that particular block, dot top. If that is less than the collision threshold, and again I need to look for which direction I'm moving in. So if it's from above, that means the ball is moving down the way, the y speed is positive. So self speed y is greater than 0. Well, in that case, I just need to flip speed y. Multiply by itself times -1. Now I just copy this down and I do the exact same thing for checking if it's from below. Check from below. And now I flip this round, rectangle top. So this is the top of the ball rectangle, and the bottom of the block rectangle is less than collision threshold. And the speed now this time, because the ball is moving up the way to collide from below, the y speed must be negative. But the reaction is still the same. I just flip it. Now I can copy this down again, both of them. And this time I'm looking for collision from the left-hand side. So this will change a little bit. Now it's going to be the right-hand side of the ball colliding with the left-hand side of the block. And that would mean that the ball is traveling to the right, so the x speed is positive. So then we just flip the x speed. Now look for collision from the right, and you can guess where this is going. If it's from the right, then that means that the left-hand side of the ball has collided with the right-hand side of the block. And all I need to do is look for a self speed that is negative, because the ball is moving from right to left. So then I just flip the x speed. Okay, so that's going to be detecting the collision. However, because I've made the game a little bit more complicated in the sense that the blocks each have a strength value, I now need to reduce the strength of each block that I've collided with. So this has confirmed that I have a collision, and then this section has confirmed which side the collision has come from. So now I need to reduce the strength. So first of all, I'll add a little comment here, reduce the block's strength by doing damage to it. So I want to check how much strength it actually has first of all. So wall.blocks, so remember this is my this is that list from my wall instance. And now I need to be able to access this particular row and item, okay? Because I'm iterating through them. So I'm going through each row and I'm going through each item, but these are just giving me lists. So I can't tie them directly into an index. I can't, using these values, directly or easily go into my wall blocks list. So I'm just going to add counters here. For row in wall blocks, I will add an item counter. I'll reset that to 0 to start with. And above here, I will add a row counter. I'll set that off as 0 as well. So now I can check, using these two counters, I can check the index of that particular block. So what I want to access first is the row count. This is going to tell me which row I'm in. So at the moment, I'm referring to index 0. As the loop goes on, down further below, I'm going to increase this counter. But to start with, I'm only iterating through the first row. So if my first row, and from that first row, I'm looking for an item count, which is going to start off at 0 as well. So on the first iteration, both of these values will be 0. So this is going to be my very, very first block. So it's going to be in the 0th row, so the first row, and index 0 item, so my first block. And now we need to access the strength of that block. And again, if you remember, the list contains two items, the rectangle at index 1 and the strength at rectangle at index 0 and the strength at index 1. So it's the strength that I'm after. If this is above 1, then I just need to reduce it by 1 because I'm doing damage to that block. So the same value, but I just reduce it by 1. However, if that wall was already on a strength of 1, so this would be the last stage before the block breaks, well, I've just done damage to it, so I don't want to reduce it down to 0, I just want to break it. So I can take this value, type it in here, and essentially to break it, although I am using lists, which means that I could simply drop this value from my list, I don't want to remove it completely because it will mess up the orientation and the positioning of all the rest of the blocks. They will all readjust because I will have lost one of the blocks completely from the list. So instead of deleting it, if you remember, this is just a rectangle. So this rectangle has an x and a y coordinate and a width and a height. So I will just set this to all zeros. So 0x, 0y, 0 width, and 0 height. So the rectangle will still exist. That block will still be within my list. It's just going to essentially have no properties. So it will still try to draw it, but there will be no width for it, no height for it. So it's not going to be there. Now, if you remember, I had this wall destroyed condition set to, well, I can say true or I can use 1. In this case, I'm just using 1. So I've got this set to 1 to start with. And now I want to check whether that is the case. So whether the entire wall has been destroyed or not. And I'm going to add a little note first. So check if this any block essentially, at the moment I'm iterating through all of my blocks. So check if block still exists, in which case the wall is not destroyed. So if wall blocks, which is my list, row count, which is the row that I'm in, item count, which is the item that I'm looking at the moment, and rectangle, if those values, whoops, I've gone down here. If it's not equal to this value of 0, 0, 0, 0, then that means that at that point, or in that position in the list, there is still a block. Because if that block was destroyed, then I would have set it to these values. So the fact that it's not those values means that it still exists and it still has a strength. So if that is the case, then the wall can't be destroyed. So wall destroyed is 0. And now that I've done all that, it means that I've finished checks completely for one of these blocks, so I can move on to the next block. And to do that, I just increase my item counter. So item count increased by 1. And once I finish that entire iteration for every item in the row, I want to move on to the next row. So I want to increase my row count. Increase row counter. Plus 1. So lastly, now that I've gone through at the end of this iteration, I will have checked every single block. And if I have got a collision with the block, then I will damage that block. And if the block is completely broken, then I will delete it. Not from the list, but from the game board. So this last section, once the iteration is complete, I want to check, and I'll just add a little note here. So after iterating through all the blocks, check if the wall is destroyed. So if wall destroyed equals 1, which, if you remember, that is how it starts off. So wall destroyed began as 1. As soon as I find a block within my entire list, entire wall, that is not destroyed, then I reset that to 0. But if it still says 1 at the end of all that iteration, well, that means that all the blocks are gone. So if that is the case, then the game is over. So I can set my game over variable. And this is where I differentiate between the two. So if we come down here, previously when I was looking for the rectangle, i.e. the ball going off the bottom of the screen, I'd set game over to -1. This gives me a condition of a loss. So the player is lost because the ball has gone out of bounds. But if you've destroyed the entire wall, then the game is still over, but the condition is different. So I'm going to use a 1 for this instead, which means the player has won. Okay, so that was quite a lot of typing, and there's a possibility that I did make a typo along the way. So I'm going to run the code just to check, and I have indeed. Oh, I copied and pasted the wrong thing there. Okay, and there we go. It's working straight away. So you can see as it goes along, it's breaking these blocks. and it detects which side it's hitting them from, so it bounces off in the right direction. So if I keep going, I want to see if I can hit one of the green ones, because the red ones destroy straight away, but the green ones shouldn't. They should lose. There you go. So they lost 1 point, and it just turned to a red one. So if I kept playing, that would be the same case when I got to the blues. They would go down to green, and then they would go down to red. So I know that collision was probably a little bit confusing to understand, and maybe a bit tricky to follow what exactly I've done here. I've tried my best to explain it, but if it still doesn't make sense, then just feel free to ask any questions in the comments, and I'll explain it. Collision in Pygame, I mean, there's many different ways of doing it, and it's worth a video on its own just to explain all the different methods of how you can do collision. So for now, that's everything for this video. If you found this useful, then please do leave a like. And if you want to stay up to date with future tutorials, then feel free to subscribe. Thanks for watching.